All right, this lesson is all about conditional probability. So, you guys have been working with probability before. This is a very special kind of probability. It is the probability of one event happening given that another event has already happened. So, this is a little different than the probability of A and B, like you learned in the last lesson. It is not calculating the probability that two things will occur. It's calculating the probability that one thing will occur, knowing that with 100% certainty, another thing has already occurred. Okay? So that was a lot of words. Let me just interpret what this right here means. So this is the probability, there we go, that event A will happen. Knowing that event B has already happened. Okay, and the way we would read this is the probability of A given B. That bar right there means given. It is information that has been given to you already. Okay, so there's two different formulas, one for the probability of A given B, the other for the opposite, the probability of B given A. All right, let's look at an example of conditional probability. And be careful, we're going to look at two examples because it is different depending upon whether or not you're talking about dependent events or independent events. So these are dependent events. In other words, these are events that directly impact each other. So it says, what is the probability of rolling a dice and its value is less than 4? We're going to call that event B, and it is blue. And then given that you already know the value is an odd number. So this is event A. All right, so I need to figure out what is the likelihood that I roll a dice and I get a number less than 4, knowing already that I also know it's going to be an odd number. All right, so the probability, the formula is given right here to you, but the probability of event B given event A is equal to the probability of A and B divided by the probability of just A. So I need to figure out what these two individual pieces are. First, the probability of A and B. And once I know those two things, I can plug them into my formula and I can be done. So the probability of A and B, this is the probability that you roll a die and get a number less than 4, and that number is an odd number. So if we look at this diagram, 1, 3, and 2, these are the numbers less than 4. 1, 3, and 5, these are the odd numbers. There's only 2 of them, 1 and 3, that fit into both categories. All right, so I would say there are 2 numbers out of 6 numbers on a die. And so I have a 1/3 probability of getting a number less than 4 and an odd number. Now I need to figure out just the probability of A. So remember, event A is all of the values are odd. Well, that is 1, 3, and 5. So there are 3 out of 6 choices on a die. In other words, I have a 1/2 probability. So to figure out the probability of B given A, I need to take this one, which is 1/3, and divide it by the probability of A, which is 1/2. And remember, when you divide by a fraction, it's the same as multiplying by the reciprocal. So I am left with 2/3. Now, you can also use the picture sometimes to logically reason through this. So, out of the odd numbers, there are three of them. How many of them are also less than four? Two of them. So, two out of three odd numbers are also less than four. That's where the 2/3 comes from. Okay, now flip it over to the back. Let's talk about independent events. So first it says use this Venn diagram, and then we're going to determine what the probability of E given F is. And we have two events, E and F. So I'm going to go ahead and label one circle E and one circle F, and we know they're independent. Well, hopefully you remember from the last lesson that when you have independent events, this middle section in here, okay, that middle section, this is the probability of E and F. And when they are independent, this equals the probability of E times the probability of F. So I need to take 0.6 and multiply it by 0.5, and I will get 0.3. So I know that in this middle part of the circle, this is 0.3. Let me erase because it's hard to see. There we go. Okay, and it says the probability of F is 0.5. Well, 0.3 of it is already in the middle, so that means the other 0.2 needs to be in there. And then the probability of E is 0.6. Again, 0.3 of it is already in the middle, so the other 0.3 needs to be there. And then this is so far a total of 0.8, which means there's 0.2 remaining in the outside, meaning there's a 20% chance that neither event E or F will happen. Okay, now it says calculate the probability of E given F. So using our formulas from the front, the probability of E given that F has already happened is equal to the probability of E and F divided by the probability of F. All right. Now, I could just dive in and use numbers from the Venn diagram. That is one possibility. Or another way to look at it, E and F, because these are independent events, I know that this is the same as E times F. And now, hopefully, you're kind of seeing what's going to happen here. Look at how the probability of F cancels out. So I'm left with just the probability of E, which I was told at the beginning is 0.6. So for an independent event, if you are calculating the probability of one event given another event, it's just going to be equal to the probability of the first event. All right? And this only works for independent events. Okay, that is it for this lesson. Good job, everyone.